next topic of study. I'd like to tell you a couple things first before we begin an example. First of all, there are about 5 ways that you can solve a quadratic equation, and you've already done that a few times. And we probably didn't at the time call them quadratic equations. First, I'd like to just share an example with you of a quadratic equation, and basically, bottom line, is that a quadratic equation has to have a variable raised to the second power to be called a quadratic equation. It must have this term. It does not have to have an x term. It does not have to have a constant. It can have one or the other. It can have all 3, but it must have an x squared term to be called a quadratic equation. The way you've solved quadratic equations so far is you've gotten this equation in what is called standard form, where everything is on one side, 0 is on the other side. And you've factored that, and then you've used the zero product rule and you've set the factors equal to 0. We're going to remind you of that right here. You've also solved quadratic equations by graphing them. And you can do this with your graphing calculator. I don't expect you to do this by hand at this point. So I'm going to sketch graphs up on the board here, but you can use your graphing calculator to find the solutions graphically. The next method that we're going to use is called completing the square, and that's going to be in the first section of this chapter. I'm going to go into quite a bit of detail on that in this section of our little tutorial here. The next method is the quadratic formula, and I'm thinking I've missed one. Oh, the principle of square roots. That'll also be in the first section as well. The quadratic formula will be in the second section, and it'll be in our second video clip. Let's take a look at this problem, and let's remember that you've got to get it in standard form first. So this 21's got to come over to the left-hand side. So I'm going to write this equation as x squared minus 4x minus 21 equals 0. So everything's on one side, nothing's on the other. What you've done so far is you've factored this into the product of x minus 7 times x plus 3. And then you set those factors equal to 0. I'm no longer going to go through these steps. I'm just going to say that now we'll subtract 3 from both sides, and therefore a negative 3 will be one of my solutions. Here I'll add 7 to both sides, and 7 will be the other solution that works in this quadratic equation. And again, you should go back in and check these into the original equation. I'm not going to do that as well. I'm going to expect you to do that on your own. Again, put the 7 in for x everywhere you see it. Do the arithmetic, raise to a power, multiply by 4, subtract. Put the negative 3 in as well, and check to see that they both equal 21. If you were to graph this with your graphing calculator, what you would be doing, and I'm going to have to sketch this. I can't seem to get my calculator to show up on the video camera without better lighting. So in the top row on your calculator, right below the screen, are 5 buttons. Right here is your y equals button. What you would do for this problem is you would hit that y equals button, and under y sub 1 you would type in x squared minus 4x minus 21. And then all you'd want to be sure of is that under your window button right here, that you have an adequate window for graphing this quadratic equation. A quadratic equation is always going to be in the form of a U shape. It's either going to open up or it's going to be upside down. So you've got to get an appropriate window. Please remember that one way to get a standard viewing window is to hit the zoom key right now. And I've got to grab my calculator and check. When I hit the zoom key, if you select number 6 under that menu, then that will give you a standard viewing window, and you will get a graph of this equation. The graph of this equation is going to look like, and I'm going to have to go into my writing here, but it's going to cross right here, and it's going to cross right over here where x is equal to 7, and it's going to look, again, a sketch, a real not real clean sketch, but a decent one. It's going to look like this. So the second way to solve a quadratic equation is for you to check and see where this crosses the x-axis. That's where y is equal to 0. That's this right here. You've set this expression equal to y, but it's really equal to 0. So these points right here are, in this case, x is a negative 3, y is 0. That's why it satisfies. And over here, x is 7 and y is 0, and that's why it satisfies as well. So look for those points where it crosses the x-axis. There's a description in the book, and I'm trying to decide, it's on page 403. Tells you how to find these intercepts And it has to do with these keys again, and it has to do with, this is, I believe, the calc key, and this is the graph key. And you will access the feature that allows you to find these intersection points by clicking on your second key and then your calc key. And actually, I think there's something else right here. Calc is written above it. And when you access that second calc, you're going to select number 2, which says zeros of the function. It is looking for y is equal to 0. That's why they call it the zeros of the function. So you should practice that with this problem. You should be putting it into your calculator, get a good window, look at the graph, and then go second and select this 4th button over, which says calc up above it, and select item 2 under that menu, which is zeros. And it will ask you to put in the left boundary and hit enter. So I'm going to move my cursor right here. That would be considered a left boundary to that point. Hit enter. Then it will ask for a right boundary. Move it down here somewhere. Hit enter. And then it asks if you would like a guess. The book tells you to move your cursor over here and hit enter again. In reality, once you've established a left and a right boundary, you do not need to move your cursor to that intersection point as long as there is only one intersection point. And you would do the same thing over here. So practice that before you go any further. Here's another quadratic equation that we're going to solve. Now please notice it's got an x squared term. It doesn't have an x term. It just needed an x squared term to be called a quadratic equation. We're going to solve this 3 ways. First is factoring, just to keep reminding you of that. And if I were to solve it by factoring, I need to bring the 36 over on the left-hand side and set this equal to 0 so that I can use the zero product rule. I have to put it in standard form, or I have to get everything on the left-hand side to do this. And when I factor this is the difference of squares. So I have x plus 6 times x minus 6 equals 0. And the zero product rule says to set each of these factors equal to 0 and then solve for x. So here I'll add 6 to both sides and I'll get x is equal to 6. Here I'll subtract 6 from both sides and I'll get x is equal to a negative 6. If I were to graph this problem, and please I would encourage you to do that, but you have to graph it in this form right here. You have to put into your y equals under y sub 1, doesn't matter if it's y sub 1, but I would suggest that, type in x squared minus 36. And a zoom standard window is not going to work quite as well to see the whole parabola for this one. It ends up that your y values extend way down to this point, right, I'm sorry, it's right here, a negative 25. So you might want to put in a window, so hit your window key on your graphing calculator and put in an x minimum of a negative 10 and an x maximum of a positive 10. And then I would put in a y minimum of a negative 30 and a y maximum of 10. It doesn't matter there because I want to see the bottom of this curve. It's going to look something like this, where it intersects the x-axis at x is a negative 6 and x is a positive 6. And the curve is going to look, it's supposed to go through that point, something like this parabola. Again, your goal is, and if you can't see what these values are, where it intersects, is to use that calc feature, that zoom calc, and select number 2, 0, so that you can find what's called the zeros of the function, or where y is equal to 0. So find those intersection points. Thirdly, I could have just used the principle of roots, which is, I've got a perfect square on the left here, and I can go ahead and take the square root of both sides of this equation to solve for x. And what I find out is that x has got to be plus or minus 6. Remember, when you take the square root of 36, you can get a positive 6, because 6 times 6 is 36, or a negative 6, because a negative 6 times a negative 6 is 36. And of course, these answers will check back into this original equation. This is right here, 3 methods that we're going to do. Again, by factoring, graphically, and called using the principle of roots. I'd like you to know that on your test for this chapter, I'm going to expect that you'll show me that you can use all the methods. So 5 methods that we're going to be talking about solving quadratic equations. You need to be prepared to do at least a problem or 2 using every method. We'll solve this quadratic equation 2 ways, by factoring and by the means of graphing. Let's put this in standard form. So 6x squared minus 11x minus 10 equals 0. And let's factor this trinomial. Remember, this is one of the harder trinomials to factor. This has got a 6 in front. Now, I don't have time to go through the alternative method again, but in case you are using the alternative method to factor, you would be taking 6 times a negative 10. You'd be looking for two numbers whose product is a negative 60. You want those two numbers not only to multiply to be a negative 60, but you want them to add to be a negative 11. I'm actually thinking a negative 15 and 4 would be, I'm going to go ahead and follow through with this, since I was able to come up with those numbers. Negative 15 times 4, yes, that's a negative 60, adds to be a negative 11. So I'm going to write this as a negative 15x plus 4x. I am replacing this minus 11x with these two terms. Then I'm going to bring down the minus 10. I'm going to bring down the 6x squared. And now I'm going to factor it by grouping. So I group the first two, and I group the last two. And I look for the greatest common factor in each group. Here it's a 3x. So I factor that out. And I'll need a 2x minus 5 here. Here the greatest common factor is a 2. And I'll need a 2x minus 5. And if I've done this correctly, and if it's factorable, these will match. I bring that or factor that out. 2x minus 5. The 3x plus 2 goes in the other binomial. And I have successfully factored the trinomial using the alternative method. I didn't quite show all the steps. Then I would let 2x minus 5 equals 0. And 3x plus 2 equals 0, and I will solve for x. So here I'll add 5 to both sides, so I'll have 2x equals 5. I'm not going to show those steps. Now I'll divide both sides by 2, and so I'll have x equals 5 halves, or 2 1/2. Here I'll subtract 2 from both sides, so I'll have a negative 2 over there, and then I'll divide both sides by 3, and I will have x is equal to a negative 2/3. Again, there's my two solutions. If I were to graph this, one of my solutions would cross the x-axis right there at a negative 2/3, and one of them would cross right here at 2 1/2. Now please notice what kind of window I've put up here on the screen so that you can see the whole graph. So really, on the x-axis, you could open up the window to be a negative 10 minimum, positive 10 maximum. I would make sure that you had at least a negative 10 and maybe more as a minimum for y, maybe a negative 20, because the curve is going to look something like this. Just a sketch. It's going to go through the y-axis at a negative 10, come down here somewhere, and come on back up. Again, you could find these points, and that's the other way to solve this, is graphically by finding those points of intersection on the x-axis. The principle of square roots says that if you have a perfect square on one side of the equation, that you could just take the square root of both sides. So I have an expression, this is just theoretically speaking, I have a perfect square on the left-hand side, so given that, I might consider just taking the square root of both sides, and I would find out that x will be equal to a positive square root of d, or x will be equal to a negative square root of d. We often write that as x is equal to plus or minus the square root of d to save ourselves some lead and some paper and all that. So apply that to a fairly simple equation. I have 10x squared equals 30. If I could just get the x squared term alone so that it would be a perfect square, so I'm going to divide both sides by 10 to do that, then I will have x squared equals 3. And now I do have that perfect square on the left-hand side. This is leading up to the process called completing the square. And what I will do is I'll take the square root of both sides, and I would say that my solution to this equation is plus or minus the square root of 3. Let's do the same thing with this problem. Again, a quadratic equation because it's got an x squared term. But I would be able to, if I would just move that 2, that positive 2 over the right-hand side, and then divide by 3, I would have the square on one side of this equation. So first I'm going to subtract 2 from both sides. I'm not going to show the work. I'm just going to move that 2, if you will, over to the right-hand side. And then I'm going to divide both sides by 3. So I will have x squared equals a negative 2/3. Well, I'm going to apply the principle of roots property, and it says that I will end up here with plus or minus the square root of a negative 2/3. Well, you just finished a chapter that had negative values underneath the radical, and what you were expected to do was to bring out I when you had a negative 1 underneath the radical, and simplify if you could. The 2/3 in itself can't be simplified, but I don't want to leave a radical in the basement, remember? We never leave that radical downstairs. So think of this as plus or minus I times the square root of 2 over the square root of 3, and we're going to multiply top and bottom by the square root of 3 because that will eliminate the radical downstairs. That will give us 3 downstairs, and we'll have plus or minus I times the square root of 6 over that 3 to finish this solution. Again, not proper to leave a radical downstairs. Got to pull out the negative sign out from underneath the radical. So this is an imaginary number, and I'm done. Now, if I were to graph this problem and try to look for the solutions where it crosses the x-axis, you'll find that the graph of this equation looks something like this. It's a parabola that doesn't cross the x-axis, and that's what's going to happen when there are no real answers to a quadratic equation. So every problem that we do that has real solutions, in other words, no imaginary solutions, they'll always cross the x-axis. But if they don't, when you graph them, you know that you're going to have I in your answer, and there is no way for you to discover graphically what the solution to this problem is. You must either use this method, completing the squares, which is next, or use the quadratic formula. Take a leap in this problem in that we have on the left-hand side of this equation a binomial squared. If you FOILed that binomial out, if you multiplied x minus 1 times x minus 1, you'd have x squared minus 2x plus 1. You would have an x squared term. So first I want you to recognize that this is a quadratic equation, you just don't see the x squared term. I'm going to solve it by using the principle of roots. Because I have this square, perfect square on the left-hand side. And so what I'm going to do is I'm going to take the square root of both sides of this equation. Well, the square root of x minus 1 squared, as we learned from the last chapter, is just x minus 1. Remember, the square root of anything squared is itself. And so I have x minus 1 equals plus or minus the square root of 5. And now what I'm going to do, I'm going to go ahead and show this first time. I'm going to add 1 to both sides in order to solve for x. And the way we'll write this then, this 1 right here will be put alongside this plus or minus the square root of 5. And we'll show our answer as 1 plus or minus the square root of 5. This is the exact way to write this. If I were to want to do this with my calculator, and I'm not sure that I've done it actually in my notes, so I'll have to be careful here. If you were to take your calculator and go back to the home screen and just type in 1 plus the square root of 5, you'd get approximately, and I'm really guessing here, this is about 2 point something, 2.2 I'm going to say. So 1 plus 2.2 is approximately 3.2. And then you would take 1 minus the square root of 5 to get the decimal equivalent. And let's say again, if this is 2.2, 1 minus 2.2 would be a negative 1.2. So sometimes you are asked to get decimal equivalents of these solutions, and it is a matter of taking this plus that value and hitting enter, and this minus the square root of that value and hitting enter and getting your 2 decimal equivalents. Again, please recognize that I just estimated the square root of 5 to be 2.2. I'm not sure exactly that that's the case. If I were to sketch this one, again, my solutions are about, between a -1 and a -2, so 1 would cross somewhere right there. I actually do have notes on this, so I was correct in my guess. And the other one's going to cross about right there, and this graph's going to look a little something like that. And I would be able to find those intersection points for this quadratic equation. What you'd have to be careful if you graphed this one is you'd have to, the original problem read x minus 1, that quantity squared, equals 5. You could go ahead and just bring the 5 over and set this equal to 0, and you could just put this into your calculator and not have to do any of the algebra. You wouldn't have to FOIL this and clean it up and subtract the 5 or combine your like terms. You could put that in, you'd see this graph, and you could find those solutions where it crosses the x-axis. The next thing that we're going to do is we're going to learn how to complete a square. And quite literally, I mean at first that we're going to take a picture and complete a square. But here, I want to try to get you thinking about where we're going. It's tough. This is a really tough topic. A minute ago, we had a problem that was a binomial squared equals a number. My goal now is going to be to take an algebraic equation and get the left-hand side to be a perfect square trinomial so that I can write it in as the product of a binomial times itself, or a binomial squared. So a perfect square trinomial is one where you can factor it into a binomial times the same binomial. And so what I'm going to do is I'm going to share an example with you. I've got two terms right here, x squared plus 6x. I'm going to look to add some number to this to make it into a trinomial that is a perfect square trinomial so that I can factor it into the product of two binomials that are the same. I'm going to do this or illustrate this at first with this picture. I have here an x squared term. Would you please picture that this square right here has dimensions of x by x. So the area of this square is x squared, and I'm drawing that to represent this term right here. These sticks over here, I'm going to draw one off to the side. They are x dimension in height, if you will, and I'm going to say that they are 1 unit in width. So the area of that rectangle is 1 by x, which is 1x. So each one of these rectangles represents a 1x. And please notice that there are 6 of them because there are 6 x's here. And I purposefully put 3 of them over here and 3 of them over here. So I put half of them on one side and half of them on the other side. What I want to do now is I want to complete this square. I want to add something in here in the form of what's called a unit block. It's a 1 by 1 and its area is 1. I'm sorry, this is a little bit small. And so what I'm going to do then is I'm going to break this up into unit blocks, each one of these representing 1 unit, and there are 9 of them. All right, so 9 little squares in there, having broken the x's in half, 3 of them over here and 3 of them over here. 3 by 3 is the 9 that I have to add here. I have completed a square, and I know I can factor this trinomial into x plus 3 times x plus 3. Please notice the x plus 3 here, the x plus 3 units over there. If you check this out, x times x is x squared. Here's a 3x, and a 3x is at 6x, and 3 times 3 is at 9. And I can write that as a binomial squared. Again, that was my goal. You're going to see us do a problem here in a minute, but for right now I just want to look at how I complete the square. I was looking to take this 2 terms, add 1 to it to write a binomial squared. Let's do another. I would like to complete this square. Right now it's got the 2 terms, x squared plus 4x. And I've already drawn the picture. I've got this square, which is x by x in dimension, and its area is x squared. That's the first term. Of the 4x, I put 2 of those x's, 2 of those long parts, to the right side, and 2 down below. Would you please notice that I'm always splitting those in half? Last time I had 6 of them. I put 3 to the right and 3 down below that x squared. So split them in half. And what I want to do is complete this square with units that are 1 by 1 blocks, and it looks like I need 4 of them. This dimension here, 2 by 2, 2 squared, gives me the 4 that I need to add here so that I can write this as x plus 2 times x plus 2 when I factor it, or a binomial x plus 2, that quantity squared. Now, let's go ahead and see the pattern here. You took this number 4 and you cut it in half. So 4 cut in half is equal to 2. But then you took something that was 2 by 2, or in other words, you squared that number to get the value that you were adding to this trinomial. A minute ago, when we had a 6 here, and I'm not going to draw the whole picture, but when we had a 6x here, we basically took the 6, cut it in half, put 3 over here and 3 down below, and then once we got that value of 3, we squared it, and here 3 squared was equal to 9, and that was what the value that we added to get a perfect square trinomial. It works even if I have a minus sign here. So let's say I have x squared minus 10x, and I want to know what I should add here, and it is always going to be add. I will take the value that's the coefficient of x, so it's a minus 10. I will always cut it in half, and then I will square it. So a negative 10 divided by 2 is a negative 5. When I square that number, I get a positive 25. 25 is the value that I have to add to make this a perfect square trinomial, and when I factor it into the product of two binomials, it's going to be x minus 5 times x minus 5, because I want the middle terms to combine to be a minus 10x, and this minus 5 times a minus 5 is at plus 25. And again, now I can write that as a binomial squared. My goal is always to get the left side of the equation into a perfect square binomial so that I can take the square root of both sides. We're going to do an example now. Okay, let's solve a full problem by completing the square. Again, the fourth method that we're going to practice when solving quadratic equations. What you need to do in this case is to not put this in standard form. So this problem was given to us in standard form, so what you need to do in this case is to keep the x squared and the x term on the left-hand side, and to get the constant over to the right-hand side. That's step number 1. Move the constant to the right. Step number 2 is to look at the coefficient of the x term. We often call that the b value. Well, in this case, that's a 6. And remember, when we completed the square, we took that value, we cut it in half, or divided by 2, and we squared it. So in this case, I have a 3 squared, or a 9. That's the value that I need to add here in order to make this into a perfect square trinomial. Well, I can't just go adding 9 to one side of an equation. I have to add it to both sides of the equation to keep it balanced. So I've got to add a 9 over here as well. And what I will have now is right here, a perfect square trinomial factors into the product of two binomials, x plus 3 times x plus 3. We say that's x plus 3 squared. And over here, a negative 8 plus 9 is 1. Would you please notice that the value that shows up, it's actually right here, in this case a positive 3, is what we're going to put inside this binomial. That's what makes this, the constant part, be part of the perfect, the binomial squared. Watch for that, that'll be easier as we get doing this with fractions. Now, because we have a perfect square here, we're going to take the square root of both sides, and we'll have x plus 3 when we take the square root of x plus 3 squared. And over here, plus or minus, the square root of 1 is just 1. What you'll need to do then is you'll need to move this 3 over to the right-hand side, or subtract 3 from both sides, and you'll have a negative 3 plus 1 and a negative 3 minus 1. You should follow through with that, and you should tell me that a negative 3 plus 1 is a negative 2, and you should tell me that a negative 3 minus 1 is a negative 4. Those are the two solutions to this quadratic equation by completing the square. Let's solve another problem by completing the square. Again, remember to move that constant over to the right-hand side, since I have most everything on the left side. So we'll move the minus 10 over to the right-hand side and write that as a positive 10. You have to always take the coefficient of x, which in this case is a minus 18, and cut it in half, or divide it by 2. That value will be squared. But remember that that value is a negative 9. And when I square that, I get a positive 81. So 81 is the value I want to add to both sides of this equation to keep the balance, but to make this into a perfect square trinomial so that I can write it as a binomial squared. Please recognize that this number will always go right there, so that you don't have to think too hard in terms of the process of factoring this perfect square trinomial. But x minus 9 times x minus 9 is equal to this trinomial. And over here I have 91. And finally, I've completed the square, and now I can use the principle of square roots, which means I'm going to take the square root of both sides. So I'll take the square root of the left and the square root of the right. On the left, I'll just have x minus 9, and on the right, I'll have plus or minus the square root of 91. Again, remember, x has got to be alone because we're solving for x, so we're going to add 9 to both sides. Or in other words, I'm going to move it to the right and write it as a positive 9, and I'll have 9 plus or minus the square root of 91. This is the exact answer, the two exact answers for this quadratic equation. But if you took your calculator and took 9 plus the square root of 91, and 9 minus the square root of 91, you would have your two answers in decimal form. They're not exact any longer. You'd have to round them off, and our book suggests that you round them off to the thousands place. Solving by completing the square, the numbers in front of x are not always so pretty as the ones that we've been working with. And what I mean by that is the numbers that I've put in front of x so far have been even numbers, so that when I divide by 2, I get a whole number, and I square it, and I get a natural number. Well, that's not the case with this problem. I've got 2/5 in front of x. So when I take 2/5 and cut it in half, I basically multiply it by 1/2. And that value I'm going to square. If I can reduce it right now, I will. So 2 goes into each of those once. And so in reality, what I'm taking is 1/5 and squaring that. And 1/5 times 1/5 is 1/25. That's the value that I want to add to both sides of this equation in order to make that into a perfect square trinomial. So that now I can write that as the product of two binomials squared, but those binomials are exactly the same. And because I have a plus sign right here, I'm just going to add 1/5. If you took this on the side of your paper somewhere and wrote down x plus 5 times x plus 5 and used FOIL to multiply that together, you would get your x times x is your x squared. Your 1/5 x and 1/5 x adds to be 2/5 x, and 1/5 times your 1/5 will give you that 1/25 when you FOIL that. Over here, the 4/5, I'm going to write as, I'm going to go ahead and jot this in here right now. I'm going to multiply it by 5/5, so it'll become 20/25, and I'm going to add that to 1/25, so the right-hand side of my equation will be 21/25, and on the left side I have my binomial squared. So I'm ready now to take the square root of both sides, so I'll take the square root here and the square root here, and I'll have x plus 1/5 equals plus or minus. Please think of these as quotients individually so that you can simplify, because sometimes you'll find that that denominator is going to be a perfect square. So really this denominator will, this will turn out to be plus or minus the square root of 21/5. I think I'll go ahead and take the time to write that. And all I need to do now, in order to solve for x, is to get this positive 1/5 over to the right-hand side. I'm going to write it on the right-hand side as a minus 1/5. I'm going to bring that up over here. So I'll have x equals a minus 1/5 plus or minus the square root of 21/5. And those have a common denominator, so I'm going to slide the numerators together, and it'll look very similar to what we've been doing so far. And I will have x is equal to a negative 1 plus or minus the square root of 21 in the numerator over the common denominator of 5. And that can't be simplified at all, so I'll leave it at that. Again, if I wanted to take my calculator, this is what I would do. This is how I would do this. A negative 1 plus the square root of 21, I'd hit enter. Find out what that numerator is. You're telling it to do what's upstairs first. Then I would hit divided by 5 to get my, my decimal form of this answer. And a negative 1 minus the square root of 21, I'd hit enter right now, and then I would divide that by 5 to get the other answer in decimal form. Again, our book asks us, if they want the answers in decimal form, to just round those to the thousands place. Completing the square. The one last thing I'd like you to notice about this problem is every problem we've done so far has had a 1 in front of the x squared term. And that's the only way to complete the square, is if you have a 1 in front of the x squared term. And you have to think back to those pictures I drew. I had an x squared block. And the only way to turn this into a perfect square is to have just a x squared block. The next problem that we're going to do is going to show you how you deal with that if there was not a 1 in front of the x squared term. Okay, this is the last problem that I'm going to share with you with regards to completing the square. So, would you, as before, always move the constant term over to the right-hand side first? So, the 26 right here will become a minus 26 on the right. Next, would you remember that these problems cannot be solved by completing the square unless you have a 1 in front of the x squared term? So what you have to do is you have to divide both sides, in this case, by a 2. So this will become a 1x squared. So if I divide that by 2, then I have to divide this by 2, and I have to divide this by 2. Because what I do to one side, I have to do to the other side. So what I'm left with now is x squared minus 4x equals a negative 13. And now I'm in a position, because I have a 1 here, to go ahead and create the perfect square. So I have to take this minus 4, cut it in half, square it, but I'll always first write this division down as a negative 2, and when I square it, I'll get a positive 4. You're always going to get a positive number you're going to add to both sides, in this case 4. But I want you to notice this minus 2. That's what goes in your binomial. It's x minus 2, that quantity squared, because I want the minus 2 times the minus 2 to be a positive 4, but I want the minus 2 plus the minus 2 to be a negative 4. So I always use that value right there. On the right-hand side, a negative 13 plus 4 is a negative 9. And now I'm going to take the square root of both sides. So I'll have x minus 2 equals plus or minus the square root of a negative 9. Would you please immediately turn that into 3i? Remember that from the last chapter. The square root of a negative 1 is I. The square root of 9 is 3. We'll put those together as a term and call that 3i. Finally, I'm going to move the 2 over to the right-hand side. It'll become a positive 2 plus or minus that 3i, and I'm finished. I've got my solution. There are two solutions. There's nothing more I'll do with this one, and remember, if I were to graph this would not cross the x-axis. This concludes our look at the first section, which reminded us how to solve quadratic equations by factoring. It reminded us how to solve quadratic equations by graphing them and finding the points where they cross the x-axis, if they do, if they have real solutions. It looked at the principle of square roots, so we are taking the square roots of both sides of an equation to solve, and finally we finished with completing the square.